This question is taken from heat transfer subject VTU model question paper 2. This question number 4b. An iron sphere of diameter 5 centimeter is initially at a uniform temperature of 225 degrees centigrade. It is suddenly exposed to an ambient at 25 degrees centigrade with convection coefficient of 500 watt per meter square Kelvin. First, calculate the center temperature 2 minutes after the start of the exposure. Second one, calculate the temperature at a depth of 1 centimeter from the surface after 2 minutes of the exposure. Third one, calculate the energy removed from the sphere during this period. Take thermophysical properties of iron plate as, whereas thermal conductivity K is 60 watt per meter Kelvin, density 7850 kg per meter cube, specific heat Cp is 460 joules per kg Kelvin, whereas alpha thermal diffusivity 1.6 into 10 to the power minus 5 meter square per second. So we'll solve this problem. So first, the given data will write D equal to 5 centimeter diameter of the sphere. So we have written it in meter, 0.05 meter. Initial temperature of the sphere is 225 degrees centigrade. Ambient temperature is 25 degrees centigrade. Heat transfer coefficient, that is convection heat transfer coefficient, is given 500 watt per meter square Kelvin. So this thermal conductivity value is given in the problem 60 watt per meter Kelvin, whereas density rho is 7850 kg per meter cube. Specific heat Cp is 460 joules per kg Kelvin, whereas alpha thermal diffusivity is given 1.6 into 10 to the power minus 5 meter square per second. So first we will calculate the Biot number. Biot number is given by the formula H into R divided by K. H value already given in the problem, heat transfer coefficient H 500 watt per meter square Kelvin into, where diameter is 0.05 meter, where our R will be 0.025 meter divided by thermal conductivity K is 60. So this value is 0.208. So next we will calculate the Fourier number. Fourier number is given by the formula alpha T divided by R square. So where alpha, that is thermal diffusivity, is given in the problem, this value 1.6 into 10 to the power minus 5 meter square per second into, where T we will substitute 120 seconds, because in the problem first calculation he has given, calculate the center temperature 2 minutes after the start of the exposure. So 1 minute 60 seconds, 2 minutes it will be 120 seconds, where R is 0.025 full bracket square. So if we will simplify it, we are going to get the value 3.072. So now we will calculate the center temperature of the sphere after 2 minutes when it is exposed to the ambient. So we are having the formula T minus TA divided by Ti minus TA. So this value we will calculate it from the graph. So we have referred data handbook CP Kodandaraman, page number 72. So on the x-axis Fourier number values are given, and in the graph Biot number graphs are given. So based on the Fourier number and the Biot number, so we are going to calculate this value as 0.18 from the graph. So on the x-axis, on the y-axis, T minus TA divided by Ti minus TA values are given. So this value we have taken it from the graph. So this T is nothing but the centerline temperature of the sphere, where Ta is ambient temperature, Ti it is the initial temperature of the sphere 225 minus 25 equal to 0.18. So we'll simplify it. So t minus 25 is equals to 225 minus 25 into 0.18. So t minus 25, so if we'll simplify it, we are going to get this value as 36. So therefore t equal to 25 plus 36, t equal to 61 degrees centigrade is the center line temperature of the sphere. So first part we have calculated now. So now let us calculate the second part. So again we are having the same formula, that is T minus TA equal to TC minus TA, where TC is here, it is the center line temperature of the sphere. So this value we have taken it as 0.95 from the graph. We have referred page number 73. So this, how this value we have got, I will tell you. So on the x-axis Biot number values are given. So in the graph these values are given, r divided by r naught. So various values are given. So we have to calculate this r divided by r naught value. We have to calculate it first. So our radius of the sphere is 0.025 meter, whereas this r, this small r, so in the problem he has asked us to calculate the temperature at a depth of 1 centimeter from the surface after 2 minutes of the exposure. So our radius is 2.5 centimeter of the sphere. So he has asked us to calculate what will be the temperature at a depth of 1 centimeter from the surface. So if we will calculate the distance from the center of the sphere, it will be 1.5 centimeter from the center of the sphere. What will be the temperature? So therefore this r, small r, will be equal to 1.5 centimeter. I have written it in directly in the meter. It is 0.015 meter. So r divided by r naught, this 0.015 divided by r naught is 0.025. So r divided by r naught value we have got it as 0.6. So based on the Biot number and these graphs 0.6, so this 0.95 value is taken from the graph. So again we are having the same values here. T, this is nothing but the temperature at a distance 1 centimeter from the surface. So what is this temperature? We have to calculate now. So T again ambient temperature. So TC here we will substitute. TC is 61. Already we have calculated here. 61 degrees centigrade is the center line temperature of the sphere. 61 minus 25 degree equal to 0.95. So here T minus 25 equal to 61 minus 25 into 0.95, cross multiplication we have done. So if we will simplify this, we are going to get 34.2. So therefore T equal to 25 plus 34.2, that T temperature T will be 59.2 is the temperature at a depth of 1 centimeter from the surface. So now last we will calculate. So what is the energy removed from the sphere during this period? So again we are having, we will calculate these values from the graph only. Q divided by Q maximum. So we'll refer page number 74. So on the y-axis these values are given, Q divided by Q maximum. So before calculating this, we have to calculate this value, Biot number square into Fourier number, because this is on the x-axis in the graph. So in order to read this value, we have to calculate this value first. So Biot number square into Fourier number. Biot number already we have calculated, it is 0.208 bracket square into Fourier number is 3.072. So Biot number square into Fourier number will be 0.133. So this value along with in the graph Biot number values are given. So based on this Biot number square into Fourier number and along with Biot number graph, we have calculated this value 0.8 from the graph directly. So in order to calculate this Q maximum, we are having the formula, that is M into Cp Ti minus Ta. So we don't know M value, mass. So whereas mass is given by the formula to calculate mass as density into volume. So this density already it is given in the problem 7850 kg per meter cube, where volume of the sphere is given by the formula 4 upon 3 pi r cube. So this density 4 upon 3 pi, where R is 0.025 meter cube. So M value will be 0.513. So Q, we will substitute this value here. M is 0.513. So this Cp, specific heat in the problem, he has given in the joules per kg Kelvin. So I have substituted directly in kilojoules per kg Kelvin. So I have written here 0.460, the initial temperature minus ambient temperature, 225 minus 25. So if we calculate this, Q maximum value will be 47.268 kilojoules. So therefore this Q divided by Q maximum equals to 0.8. So therefore this Q equal to 0.8 into Q maximum. 0.8 Q maximum value already we have calculated. So this Q is equals to 37.814 kilojoules or 37,814 joules.